All right, yeah, welcome back. Yeah, now I want to look at how can we apply all this also on neural networks in R. So the same process follows. We just load our libraries. We have to load library neural network. If you don't have, you can install it. Then our usual caret. All right, so we load the libraries. So they are loaded. So our data is also here. We load it here, which we have been using before. All right. So we can glimpse it first, as usual, to see what is inside. So we have see what is inside here. Okay. So we have not it has not changed. So we are going to do the same thing we did for decision random forest. Okay, we are going to apply the same thing here so that they can use this one camera we are using 0 and 1 instead of 1 and 2. All of them is okay. So our neural network start from 0. So you can use 0 and 1. So just click here, sort of so you can glimpse again. Let's summarize the data. The summary of data. So let's glimpse again. So you have 0, 0 now, and 1, 0, and 1, 0, and 1. So now let's set a seed as usual. So now I want to split the data into two samples of 17 by 30. So that's what we do here now. Just click here and split the data. Then we do training 70%, testing 30%. So what we do, same thing. So just same thing we are repeating now. So nothing changes. So let us now create a neural network now. Okay, we can set the seed for that as well, right? So now we call our function, we create a model called neural net, right? We call the function called neural net here. We function called this is a model neural model. Then now we pass our disease to the neural net function. Then we want to use all. That's why we use dot. Now our data, the data here is training data. So hidden is 4. So this is hidden layer is 4. We're using, can use 3, 4. It depends on the data you're using. So if you use 3, let's try 3 first and see the output. All right. So error feature, we are going to use a error. You can use SE, so CE here. All right. So life sign, we want it full. All right. So full, you can use full. All right. Full means to show how data is processing in full. Then linear output is going to false. Now, if you run this line of code now together, we should have this. So that's finished. All right. So let's plot the neural network. Let's see. We want to plot the model. Okay. So this is the model. Okay. It's our model. It's a neural network model. These are our target variables. This is okay. We have 1, 2, 3. 3 hidden layer. 3 hidden layers. So you can see here. Also, all right. You can save that. Maybe you can just export. Right. Save as PDF or as image. Yeah. Okay. To save it into your working directory. All right. Just give it a name. You save there, so you can see that later and use it in your analysis or your report. All right. So now, so that's what we have now. So let us now predict now. Now we have let us predict our using our testing model, our testing data. So we just want to go to the testing data straight instead of training testing as usual. So you can do the same if you want to do the same here, but I just don't want to waste time. So I've introduced to that, you have understood, so there's no problem. So I'm just trying to minimize time. So we test data. So we compute. We call computing function here. We call our model. All right. Repeat 1. Then testing data is passed here. So minus 12 minus the disease. We don't want to include this string. This particular one we don't want to be included in our. So we minus it. Okay. Then T1 is equal to T1 is testing output here. We assign it to T1. We predict here. We use a logistification method here. 0.510. Anything above 0.5 is 1. Lower is 0. So we have our table is this one is just to test. We are going to use this one later and pass it inside here. So let's just run this line of code and see what I'm talking about. Then we pass it to table 1. So now we have this. So we have 76.3 accuracy, right? Right. So that's what we have. So for our testing model. So what we need the testing model, but let's try and change to 4 hidden layer. I think if 3 is not good enough, so let's change to 4 hidden layer. That may possibly increase our accuracy. So we don't need to run this anymore, so we can just run this. Then run our functional matrix again. So we have 81.58%. 81.5%. So we can also improve on it. I don't know, we cannot use 5. 5 does not work. All right, let me try. 5 does not work. So if 5 work, maybe we'll have let's try. So it's 81.58. Any difference between that and this one? 81.58. See, so let's go back to 4. So it does not improve the. So you can add more parameters here. So the other way to get this accuracy 1/1 or this one is to put in the vector here. So you can just run this line of code like this. Okay, so can just assign it to con. It's a con underscore math, for example. It's another method to get this done. So just assign this to this and run this line of code. All right, and we now call this one C. We call this out to show us this ones. You can see this is what we needed. So accuracy, sensitivity, precision, F1 score. So we can copy this and put it in our record. So we can use this for our analysis later to show that okay, this is what we have. So this is what we have now. We have accuracy, which means that random forest it should give us higher accuracy than the rest, followed by so the maximum we have in a neural network is just 81.58%, 57% or 58%. So that is what we have in neural network. Though it can be improved upon, okay, you can improve upon this this particular and to have a higher accuracy. Okay, you can improve upon it. We can set the parameters and increase the accuracy. So you can do that later. So just learn more about neural network parameter setting. Then you can improve the accuracy. But that's just for basic understanding. You can have this now and compare your results. So I will see you later in the next class. Thank you so much for this class. I'll see you in the next class. Thank you.